Hi, I thought it's time to make a video on Alive again. If you don't know, Alive is a live coding language that I'm building for doing visuals live coding by myself, and it's been a hot minute. It's been 5 years since I made the last weekly video, so I thought it's maybe time to catch up. In that time, not that much has happened for most of those 5 years, and then in the beginning of the year, I picked it up again, and I finally got back to the original purpose, which was visuals, and mostly visuals. And there was a couple, I think, big changes that kind of made it into something actually useful to me. So I think I'm just going to run through a bunch of these little changes and try to give you a glimpse of what it looks like, what it works like at the moment. So uh, what you're seeing right now is already in Alive. I'm gonna full screen that little window, and what we have here is a code editor on the left with this file open that is the Alive source code file. We have the copilot or interpreter running here, logging to the console, and then we have GLSL view, which is a small program that takes GLSL shader code, it receives it via OSC, and it can interface with some media inputs like the webcam that I'm recording this video from. And here is the terminal feed, the standard output of GLSL view that logs things like GLSL source code errors. So the main focus is the source code over here. So one of the most important changes that happened was the introduction of these template string literals like this one here. So it's a new syntax that basically associates a string like this one here. You can see it starts with a quote and with a quote with an operator name, and then inside you can use the dollar symbol to interpolate a live value. So what I'm doing here is I'm defining up here, I'm defining the video input that I'm using. So I'm calling an operator here to say I want the video stream, and I specify some parameters such as the camera feed that I'm using and what resolution I want. And this gives me a reference of that camera feed. Basically, it tells GLSLV to load that camera, and it generates basically like a uniform value that then I can interpolate into the shader and use inside of GLSL. And in the same way, I could define a variable, let's say 4 as 2 plus 2. I need a math module for that. Okay. And then I can say that I would like my new UV coordinates to be 4 times UV. And if I use that here, then we're going to have multiplication of all of the video like that. Basically what it does is for every interpolation, if it's a value like this, it will generate a temporary name that will be something like just let's call it temp val. It inserts automatically a uniform with that name, sorry, a GLSL uniform, so it's referred to like this, and then it will also automatically send that value over, say, like this. It will send that value over OSC to GLSL view whenever there's a change to the value. I think we might have to re-trigger this. Okay, because it's yes, there we go. So it's basically syntax sugar for doing this. But it becomes very handy when you start to move, when you do a variable definition up here. It's not that useful, but it becomes very handy when you start to put the logic in line with the code. And so it just reduces all of this context switching that has to happen down to just put everything into one place. And as we'll see now in the next step, it's really, really nice together with the sequencing features. So the next thing that I'd like to show is the new time library, which is link time. So in difference to the original time module, what this uses is the Ableton link framework that automatically syncs time between clients on a network. And that also it's like a musical definition of time that has beats and bars built in with a tempo. And so to use that, I import the module, and then I'll have to define my clock. clock. And what I can specify now is whether I want it to just be a local clock, local to this Alive instance, or if I want to enable the Ableton Link syncing on the network with true, and then I specify the tempo that I want to work with. So if I can do 110 BPM, save that. And so now I can use all the timing functions from the link time module, such as, for example, the every function, which will emit a bang event every time that 1 beat passes or 2 beats passes and so on. So I can specify a bar length, for example, and have it hit on every beat. And as I said, this integrates with any Ableton Link compatible device or software. So I can pull up QuickBooks Studio, for example, here, and I just put in some of the stock patterns that it comes with. So if I can play this, and if I enable link over here, it will connect to Alive. There's a little 1 here. There's a number of other clients connected to the link network, so they know about each other now. So when I hit play here, we should see that this every one, for example, should sync to the beats, so the quarter notes of the bitway composition. And you can see that due to the way that the Ableton Link works, it's aware of the length of bars as well. So if I put an every 4 down, it will make sure the playback is always aligned to a 4 beat bar over here. So no matter when I hit play, Bitwig in this case will delay execution until it's synced again with the other one, or if you would stop Alive, it would sync the other way. So yeah, this has been really, really useful for playing live together with a band of colleagues. Now these two things, of course, you can put them together. So as I was saying before, the power of the substitution really comes from collocating these things. So let's say we want the cam to switch between just being the original video or the inverse of that video. And we want to switch that with, and here we enter a live territory, with a signal that that decays in 0.7 beats every time that there is a beat. So I'm not sure how clear that is. The decay function basically generates a value from 1 to 0 that every time that there's a hit starts at 1, and then within this time it will decay down to 0. Exactly. So if I put the music back on, we can see how that's synced. And so the every parameter, if we put in a number other than 1, the second parameter can be a delay or like an offset into the bar. So like this, if we put every 2, we'll get all of the even beats. But if you wanted to have that clap that's on every odd beat, we can do every 2, 1, and now this should be hitting on the claps. Then another thing that I can show is that aside from like live sources, like the webcam in this case, or just a recorded video that like plays back in linear time, in GLSL View I can also load a video as a 3D texture. And what this gives me is a texture, a 3D texture that has free axes to index into. So let's sample from the texture here. So instead of just the UV coordinate, I need to give a third value into the vector. And let's show that video. Okay, so this is the first frame of the video. No, that's the last frame of the video, actually. 0 would be the first frame of the video. And as we go towards 1, we're stepping through the video basically. So the most useful thing here to do is define some kind of time variable. And here we can say that we want a ramp that in the duration of, let's say, 60 bars, it will ramp from 0 to 1, and then we'll pass that in here. And so the video goes into playback essentially. But what we can do now is, for example, we can add a random number to this that we want to generate every second beat, for example. So what this will do is just randomize the playback like that. Or we could add part, like we could play with like the spatial and temporal mapping, and we could do like a slit scanning kind of effect by adding part of the x coordinate to the time, or add some noise, things like that. For example, this effect, we can make it symmetric around the center of the video, and then we can multiply this by a decay on the beat. And now if we put the music back on, you can see how you might put together something a little more interesting. Okay, so let me put the camera video back on, at least partially here. Okay. Another thing that I added to the language syntax is just the literal syntax for both structs and arrays. So you can see me using a struct here, which is just a way to group values together. It can be handy in a couple of cases because it gets serialized nicely over OSC. And the same thing is true for arrays, which have become very, very useful because they map directly to vector and matrix types in GLSL. Instead of the slit scanning part, let's just offset the video by changing vector every hit. So we can have our UV variable here again. I think we'll have to give it a different name though to be able to modify it. Oops. Okay, and we can say, for example, we want to add to this. Well, we can send in just a fixed value like this, for example. So that's a x and y back 2. Or we could say, for example, that we want to switch between these different values. And we can say we want to switch every single beat, for example. And maybe that's a little more interesting if we use it to invert the video in different directions, for example. So yeah, it's been mostly ergonomics really that have changed. But just the sum of these little ergonomic things has made a really big impact on the usability of the language, I would say, and has allowed me to actually use it like in a live setting a couple times now. Oh, another little ergonomic thing that I've added to the time library is the fade function, which is really useful. So for example, I can say I want to multiply the color by a value that fades within 4 bars to 1, and it's the default value now since I just initialized it. And then if I want to say goodbye to you all, I can say thank you for watching. I want the video to go to 0 now, please, and it will go. Bye bye.